Hello everyone. In today's lesson we're going to be talking about the division properties of exponents. The objectives we have for this lesson are that you should be able to come up with the rule for dividing monomials, which monomials are something that we learned about yesterday, and we should be able to find a way to deal with negative exponents. Let's get started. I want you to use a calculator to answer these 4 questions. I'm going to go grab my calculator. You can use Desmos.com to do it, or you can use your own calculator. The first one I'll just do using my calculator. The next one I'll show you with Desmos. So we have 3 to the 10th, 3 caret key 10 divided by 3 to the 6th power, 3 caret key 6, and I get the number 81. Go ahead and put these other ones in Desmos. I'm only going to do the last one in Desmos, but you go ahead and answer the other 2. So 3 to the 8th divided by 3 to the 4th. 3 to the 8th power divided by 3 to the 4th power. 3 shift 8 slash 3 shift 6 4, and we get the number 81. So what you should see whenever you put all these in the calculator is that the answer each time, you better put it in your calculator before you listen to this part about the answer each time. The answer each time is 81. So there's something going on with these powers so that the answer is always 81. Did you know that if you do 3 times 3, you get 9. If you do another times 3, you get 27. And if you do another times 3, you get 81. So all of these powers are reducing down to 3 times 3 times 3 times 3. So what's something you can conclude about this situation? Come on, think. Something was going on with those numbers. And we have it that when numbers with exponents are dividing, when numbers that have exponents are dividing, the powers will decrease. Instead of getting larger, you're going to get smaller. The rule behind that is when numbers with exponents have the same base, the exponents are going to subtract. The exponent in the numerator subtracts the exponent in the denominator. There was maybe a question like this on Monday's lesson, and one of the videos might have talked about this already, but this is the rule that you definitely need to know. Make sure you write this stuff down. And then we're going to try this using this rule. The exponent in the numerator subtracts the exponent in the denominator. That would look like this. 8 to the 4th power is going to subtract the exponent in the denominator. So it's going to subtract 2. That would make 8 squared. 4 minus 2 is a power of 2. 8 squared is equal to, no, not 84. 8 squared is equal to 64. Remember that I do need you to memorize the perfect squares. So if you don't know them, I'm going to give you a chance right after this lesson to practice them one more time. Your perfect squares 1 through 30. Let's verify this another way. Let's just, in the calculator, figure out what 8 to the 4th power is, and in the calculator, figure out what 8 squared is. Eight to the 4th power is 4,096. 8 to the second power is 64. Let's do 4,096 divided by 64. The answer is 64. So based off the fact that this 64 showed up a couple times, that means that 4096 divided by 64 had the answer of 64. So if we just rearrange that, that means that 64 times 64 is 4,096. Because we had this, I decided if I multiplied the 64 over here, if I move this 64 from the bottom and put it on the right, multiplying the right side, then I get this equation. 4,096 is equal to 64 times 64. Where did this 4,096 come from, though? That came from 8 to the 4th power. And what do we know about 64? 64 comes from 8 squared. So each one of these 64s can be written as 8 squared. All we did was we multiplied the 64 to the right, and then we changed the numbers back into their exponent form. So if 8 to the 4th power is equal to 8 squared times 8 squared, then if I bring this back, if I decide I don't want this on the right side anymore, I want to move it back on the left where it started, then we get that 8 to the 4th power divided by 8 squared is equal to 8 squared. So the purpose of this circle of math, of pretty much starting with this, going with the numbers, and then ending back with this, with the exponents, is to show that it's really useful to be comfortable with numbers and the different ways that it can appear. You need to be comfortable with large numbers and dividing them, and you should also be comfortable with seeing it in the exponent form. The reason why I'm going to have you memorize perfect squares is because you would never recognize this as having something special with powers if you never take the time to just familiar yourself with special numbers like perfect squares or perfect cubes or 4th powers. A few years ago, I used to have my students remember up to the 4th power numbers, up to the 4th power of 1 through 5, up to the 3rd power for 1 through 8, no, 1 through 15, I think, actually, and 1 through 30 squared. And the purpose of these numbers are so that you can pay attention to cool things and come to your own conclusions besides just taking my word for it. So now let's do a couple of more examples. I want you to do these examples. You can start off by expanding them, the top and the bottom, and then canceling. But by the end, you could just do the subtraction. Or you could do both. Remember, by expanding, I mean, if that's m to the 6th power, that means m, 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 m. Divided by. Once it's expanded, if you see the same thing on the top and the bottom, they're going to balance out and make the number 1. That leaves you with m to the 4th power, which matches m to the 4th power coming from m to the 6th divided by m to the squared is the same thing as m to the 6th minus the bottom exponent. M to the 6th power minus 2 is equal to m to the 4th power. Maybe that would be better for you to use that technique for this one. Otherwise, you can go ahead and write 20 n's and cancel out 8 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I should have had 12 remaining because n to the 20th minus 8 will equal n to the 12th. Here we have 2x's, 2x's. So let's just repeat that. We have x to the fourth times x squared over x squared. These ones balance out, and it leaves you with x to the fourth remaining. Or you could see from the beginning that x squared minus the power of 2 is going to balance them out and just make x to the fourth. Here we have p to the 7th minus 7 equals p to the, what is 7 minus 7? It's not 1, it's 0.